Okay, hello everyone. Hello everyone, welcome back. Welcome back to Calculus 1000. Today we will start a new section of the book. It's called Related Rates. It has two parts. I am trying to separate these two parts. One part is the mathematical theory behind the story, and the other part is the modeling. For the mathematical part, we will start with examples. We try to get some work done. But for the modeling, at the end of this session, we will have a chance to go over maybe one or two examples and set up the generalities, how this works. But we need to have more examples. So that's what we will do tomorrow. Today is beginning of the story, some serious stuff, but the section 3.9, I believe. Oh, I'm very bad with the section numbers. The related rates, we will finish it tomorrow with more details. Before I start, is there any questions, any comments that you have before we start the new topic? Okay, and I'll just let you know that we will have iClicker today, iClicker problem today. When we get to the right point, I think, yes, I have the problem ready here, and probably we will have it in sometimes before, somewhere in mid-class, so just to let you know. Okay, let's see what are we trying to cover today. So this is called related rates. But this story, the mathematical side of the story, I'm not separating modeling from math there, but I want to separate this specific part and focus on the equation level and what happens in the equation level. And the mathematical side is very simple, nice story that comes down basically to this thing, that if x and y are related, how two variables are related in mathematical language is through an equation or bunch of equations. Here we are only working with one equation. If x and y are related through an equation, so changing one would pose some changes on the other one, then you can find a relationship between their rate of changes with respect to a third variable. Let me write it down, and then I'll tell you what does this mean. So then rate of change of x and y with respect to a third variable t, usually we take t as time. So if one of the variables changes with respect to time, then the other variable also will change. And this relationship, the rate of change of these two, which we denoted by dx dt, dy dt, are related through some other equations. So if x and y are related, then dx dt, dy dt must be related as well. Let's run this example here. So if I have x squared minus y squared equal to y, so this is a relationship between x and y. my claim is that relationship will imply a relationship between dx dt and dy dt. So rate of change of x with respect to t, and this guy is rate of change of y with respect to t. The claim is they are going to be in some ways related. And this is the first step I want you to understand. How do we find the relationship between dx dt, dy dt? Or is there any relationship between these two? So that's the whole point. The claim is that this relationship can be found by differentiating the given equation with respect to t. They're related through an equation that can be found by, oh my God, I don't have enough space here, by differentiating the original equation with respect to the third variable x and y themselves are given, so the goal is to find how dx dt, dy dt are going to be related. Let's apply this to this example. What I meant there is just a simple differentiation. You're differentiating both sides of an inequality, and since you started with equality, you have to end up with the equality as well, yes? The only, differentiating, you already done so many of them, so differentiation rules will work as you know. So here I have difference rule or subtraction rules. Summation rule, doesn't matter, you can call it that way. The only thing that we have to be careful here is that now we are not differentiating with respect to x. We are not differentiating with respect to y. We are differentiating with respect to t, a third variable, time, a parameter, something else, something other than x and y. And what does that mean is that the x here is not anymore your independent variable. It's not the variable that changes. Now the time is your differentiating variable. Why should I care about it? Because if you differentiate if you differentiate x squared with respect to x, you should get 2x. But when you're differentiating with respect to a third variable, you have to apply the chain rule here. So dt of x squared is not 2x. It is 2x times rate of change of x with respect to t. Do 2 dx dt times x. And that is everything that you need to know, or everything that may sound new to you. Because before we used to differentiate with respect to x, and derivative of x squared with respect to x is 2x. Now we are differentiating with respect to t, so the derivative of x squared is not 2x. It is 2 dx dt, chain rule gives us that dx dt times x. And the same story goes with y squared, and then equals to, the right-hand side was already dy dt. That's already what we wanted to find. That is an equation which has not only x and y, but also dx dt, dy dt in it. In other words, I can rearrange this thing and write it this way. So do 2x dx dt is equal to 1 plus 2y dy dt. Yeah? And isn't that the relationship we wanted to find with, between dx dt, dy dt? We wanted, or we claim that there will be a way that dx dt, dy dt are related, and that's the equation that we find. What kind of things this can do? If someone tells you, for example, x is equal to, okay, I have to use my notes so that I don't use awful numbers there. If I have, for example, x is 0 and y is equal to 1 or negative 1, then we can find dy dt. And that's obvious now because we have an equation that includes all x, y, dx dt, and dy dt. If I evaluate these ones, then I would get that's equal to 0. And using just that equation. I'm putting the last step out as just an example that, yes, that equation will fix some stuff for us if we know enough information here, value of x, value of y, value of dx dt, then we can know what is dy dt, and that's how these two are related. This is the mathematical or equation-related side of related rate problems. And I want to do 2 more examples before we move to the actual related rate problems, which are word problems, and we have to start with modeling and then go into this. Before I go on and write the example, is there any questions, any comments? Yes, please.
How do we find dy over dt over there?
I just plugged in the values, yes? So if I plug in 0, the left-hand side is 0. X, this is 0. This is going to give us, I don't know, negative 1. dy dt times negative 1 is equal to 0. So dy dt must be equal to 0. Yeah? Let's do a very similar example along those lines. Find dy dt if, dy dt at 1 and 4 when dx dt is negative 3, if we know that root x plus root y is equal to 3 for all those values. The slogan is, xy is related, their rate of changes are going to be related. How do we find the second relationship? By just differentiating the original equation with respect to the third variable. Please go ahead. I'll give you 90 seconds. Please talk to someone if you don't know where to start, and do something in this 90 seconds. Go ahead, please. 90 seconds starts now. thing. It's not d times y over d times t.
Oh, so for x, when you plug in, it would just be 0 multiplied into it.
Yes, yes. dx dt, whole thing is one box. You cannot
Thanks.
see. Okay, good. 50 seconds left. So it's straightforward, yes? So you start with the fact that so you start from with the fact that this is how x and y are related. And to find the relationship between dx dt and dy dt, the rate of change of x and y with respect to t, I just need to differentiate both sides. d dt of root x plus root y equals to d dt of 3. And when I'm differentiating, well, derivative of root x with respect to x is 1 over root x, yes? 1 over 2 root x, sorry. 1 over 2 root x. But x, we are differentiating with respect to y. So the chain rule says that you have to multiply that by dx dt, yes? The same story is for y, dy dt, 1 over 2 root y. This is equal, the right-hand side is constant. Derivative of constant with respect to any variable is 0. There we go. We have the relationship. So now dx dt times 1 over 2 root x is going to be negative 1 over root 2y dy dt. That's the relationship we are interested in. And then, well, if you have values, just plug it in. So here I have x is 1, y is 4. So I go ahead and say that, OK, 1 over 2 root 1. dx dt is negative 3 equals negative 1 over 2 root 4 dy dt. So you're solving now. You have an equation, simple equation. And you need to solve it for dy dt. And that's how you find dy dt. In this case, dy dt oh, this is simple. This is just negative or positive 6, actually. Negative 3, then you have 4 times negative 3 divided by 2. By negative 2, that is, you get 6. Any questions? Yes, please.
Why is it not negative 6 again?
6, not negative 6.
Why is it not negative?
Oh, see, dx dt is negative 3 itself. Yeah, and then that will fix the issue. There is a negative on the right-hand side, there's a negative on the left-hand side, and then they will cancel, yes. Any other questions, any other comments? Yes, please?
Why does
Yes.
1 over 2 square root of x goes behind dx dt? Isn't it like dx dt and then your value, but then like
2 times 3. No. Listen to me, sorry. 2 times 3. If I say it's 3 times 2, would you ask why? That's the same reason. There are two quantities. At the end, you have to look at them as 2 quantities. You can either write it this way or that way when it's multiplied, yes?
So the form is right both ways.
That's exactly. So the order of the multiplication of numbers or quantities that are real valued really doesn't matter which order you do. And to be honest, I didn't achieve much by changing that order. It just like looks, I don't know, a bit better. I cannot even say it is looking better. Just I felt that way. Yeah. Okay. Any other questions or any other comments? Should we start the iClicker question maybe? Oh. Can anyone please confirm that you can see it, or is it clear enough that you can read it there? No, it's not clear. Yeah, I don't know why this thing is showing that way. Okay, I'll try to. I'll write it up here because it doesn't seem very clear over there. So the equation is 3x plus y is equal to 3x plus y is equal to 2xy. Find dy dt if x is 1, dx dt is 2, and y is 3, yes? I just want to make sure that I'm not missing any positive, negative, yes? And then the answers are 6, negative 6, 12, 18, and 2. Okay, so the timer is already on, but yeah, I'll wait another 90 seconds for you to complete that. Okay. I will start the solution in 30 seconds. Okay. The relationship between the x and y is given to find the relation between rate of changes. I just need to differentiate both sides with respect to t. And that will give me 3 dx dt plus dy dt equals to 2. So this is product of two expressions. I have to apply a product rule. 2 dx dt times y plus 2x dy dt. That equation has everything that you want. I just want to rewrite it to have dx dt one side, dy dt on the other side. Mathematically, I'm not adding much here, but just to make it a bit more cleaner. So there is a 3 here. There is a, oh, yes, there is a 2y here. And then I brought it to the left-hand side. That's where the negative comes from. And here I have 2x minus 1 dy dt. It's just rearranging things around. Now I have to plug in the values. X is 1, so I have 3 minus 2 times 3. Y is 3. Dx dt is 2. X is 1. 2 times 1 minus 1 dy. So this tells me that the left-hand side is negative 3 times 2 is negative 6 equals to dy dt. And that's what we were looking for. Did you already have the answer in? I'm closing the iClicker. Okay. So this is only half of the story. The main part of this story of the related rates comes in the word problems. And here I'll try to go through some of these. Oh, I'll keep this one. I will write it over here just. Okay, when we say related rate problems, what we really mean is these are word problems that are kind of looking for some rate of changes based on the given information. But the key point here for me is to write our word problems. And when someone says word problems means one important thing for us. It means that we are not going to see any equations. We are not going to see clear variables. We won't see how these variables are related. We will give us a story, a scenario, a situation. And now, as the problem solvers, we are responsible to figuring out what is the mathematical story behind that. So always it will start with modeling. And by modeling here, I mean specifically turning all the words, all the story in the question into mathematical sentences, mathematical expressions, things that mathematically make sense without knowing the meaning of the words, yes? When you do modeling, you translate words into equations. Now, the second part is solve the model. And here, specifically for the related rates, solve the model means really this. You will be able to find out what is the relationship between two variables, and you are going to find how their rates are going to be related. So we have done the second part. Now I want to focus on the first part, and we will start with an example, and then I will write down what are the general story there. Before I start, is there any questions so far? Someone wants to ask or? Okay, then I will write down this example, and then we go through it, and along those lines, I will explain what we are doing. Example, all sides of a cube grow with so we have a cube. The sides start all together, grow by that rate. Grow with the rate of 9 centimeter per minute. So they're increasing with that speed. Find the rate at which the volume of the cube very simple problem. It's just like the simplest kind of problem we can get. But I will let you talk to your friend for 45 seconds. The aim is not to solve the problem. No, it's not. I want you to talk to your friend about the modeling process. If you just know that, modeling means turn the words to equations, to variables. And again, I'm not interested in you going ahead and writing everything. I want you to talk to your friend about what are the important things that we have to see there, and start this process of modeling this situation, okay? Does that make sense? Does it make sense? Okay, then 45 seconds. Go ahead. We are not looking for the final answer. We are looking for what are the important components in this process.
It's cute, right?
So after
10 more seconds, and then we wrap up. Okay. Does anyone want to share what was the one or two important steps that you were talking about, or you and your friend decided to take when you come up, you have this problem? Yes, please.
Of which
The equation that relates the side to the volume. That is basically where we are going, yes? We are trying to find these equations. But before that, what is volume? How are you going to write in the mathematical wording what is volume? Yes?
like X and then label that width is equal to height, which is equal.
Thank you. So you're saying that volume is side, in the case of cube at least, to the power 3, yes? Would you be okay I'm writing every time equation like that? Well, I don't think actually, no. I should say I am okay if we continue doing this. But to be more equation-like, or more mathematically looking writings, instead of using the words, we have to decide or replace the words by variables. And this is the key point. If someone gives you a word problem, you know that it is mathematically, can be modeled mathematically. You try to identify the quantities that are important in that scenario, in that problem. What are the quantities that are important in this case? Yes?
Side length is represented by x, so you could use something like y to represent volume.
So before even relating things, you should be able to see, you somehow saw it, yes? You're already using it, you are talking about it. But if you want to be able to find a pattern that you can take with you and do a bit more complicated problems, I think always starting with this step is very important. Identify the quantities in your problem that are interested and you feel that it will be used in some ways. In this case, well, for sides are definitely there and volume is there. Should I also choose something for the rate of change of side? Should I be interested in rate of change of side as a variable itself? Well, once you have x, dx dt is going to give you that rate of change. So even though it is an important quantity, how it grows, but you don't need to introduce new variables for it. So keep in mind, I'm identifying quantities, and I want to choose some variables for it, so that we can get out of words as much as possible, yes? And then, yes, after you assign the variables for it, now I can write that relationship or find a relationship between these things. And in this case, that's a simple relationship as v is equal to x cubed, and then we have our equation. This is an interesting and exciting point because now we have an equation. I can go ahead and try to apply whatever I learned before. But before that, I would ask you to stop for a second and try to write everything else written in that problem in terms of the variables that you have already introduced. For example, how can I write this thing given in my problem? It says it's a piece of information, and if my goal is to translate everything from words to equations, to mathematical objects, I have to be able to write down this. Oh, I already did write it there. So dx dt, it was not supposed to be written that way. 9 centimeters per minute. That's one thing, yes? Another thing is, the question is asking at what rate the volume will change. In other words, the problem is interested in what is dv dt. I'm trying to find rate of change of volume of this specific case. Is there anything else left there that I didn't write? Is there anything else? What is that 10 centimeter? What should I do with that? It is saying find dv dt, but when? When x is 10 centimeter. That's specifically the condition that we have to put there. What was that? Oh, I didn't write that. Damn it. I have been walking between my tablet and my board that I completely forgot that. Ha. So, find the rate at which the volume changes when the side are 10 centimeter. Yes, you're right. Ah. Okay. Yes, I think start with variables, end with the point, the modeling, end the modeling, the point that if someone understands mathematical expressions, I have to write all these information in the mathematical sentences such that the person or the AI, whatever it is, they don't need to know English at all. If they know math, they can solve everything now. That is where I'll say my model is now ready to go. I have an equation, I have all the information written in the terms of the given variables. Now the question is that, okay, what should I do then? Now I'm done with the modeling. I want to solve the model here. Would you like to do that one yourself? No? Yes? Please go ahead. You only need 40 seconds to finish that. V is equal to x cubed and dx dt is given. We are looking for dv dt when x is 10. You start with differentiating both sides. And then you get rate of change of v is equal to 3 rate of change of x times x squared. And this is one of the easy cases where you just need to plug in 3 dx dt. Dx dt is 9. Well, no, sorry. Yeah, it is 9. And x itself is 10 centimeters. Do I care about the units? Not really. I can say that even if you don't put those units and you do it correctly, I'm okay with it. There shouldn't be any problem there. But sometimes writing down the units is another way to understand that what you have done makes sense or not, if there's any unit given here. For example, here, now I have 100 here, 9 times 3, 2,700. And what do we have unit-wise? I have centimeter here, centimeter squared here. So I have centimeter cubed divided by minute. And that's what we were expecting to get, yes? Volume has the unit of centimeter cubed, so its rate of change with respect to time makes sense to be like that. Before you leave, let me just at least outline the two steps, the two main steps that I would like you to practice, even if the problem is simple. In the modeling, the first thing you need to do is identify the quantities in particular those that change. So identify quantities. You may need to come back and revisit this thing, but start with that and assign them with a variable. The second thing, which is very important in a bit more complicated problems, this is the key step. We are just trying to do this so that we can find a simpler way to run the second step, which is find out the relationship between the variables and express that not only the relationship, but all the other information and all other information in an equation or mathematical format. Sometimes to do the second part, you will need to draw some pictures, some diagrams, just to help you with the situation and find the right equation. Once you've done this step, you are already here, and the last step, solve the model, is nothing but find the relation between dx dt, or the rate of changes using the given equation. Once you're done setting up the equations, it's important that modeling part, we will get back to it later on in the optimization. You have to practice. You have to try to make sure that you have a recipe to do that part. Once it's done, have a great day. Thank you.